Go ahead, Daddy.
Okay. I'm going to walk you through the Down-to-Earth Guide to Global Warming, and it's by Lori David and Cambria Gordon. Global warming is actually caused by too many greenhouse gases in the air. Greenhouse gases are carbon dioxide, methane, water vapor, and nitrous oxide. The normal greenhouse effect would have sunlight come down, it would reflect it off from the earth, and it would come back up. And there would just be enough sunlight on the earth to warm it. But the extreme greenhouse effect would trap too much sunlight down in our atmosphere and warm the earth too much, causing global warming. And then the burning of fossil fuels is the biggest contributor to greenhouse gases, and therefore the biggest contributor to global warming. We do a lot of burning on this planet. Where there's too much CO2 in the air, the sea takes up slack, soaking up the excess CO2 like a gigantic sponge. Cold seawater absorbs more carbon dioxide than warm seawater, and the more CO2 sea takes in, the warmer it gets, and they've already taken in a lot. So if CO2 emissions continue to rise, the oceans will simply be too warm to take up as much CO2 as they have in the past, causing more and more CO2 to be stuck in our atmosphere. A carbon footprint is the amount of carbon dioxide pollution that is emitted from the energy you use. So, every year, each of us releases literally tons of carbon dioxide into the air. CO2 is measured in pounds. There are 2,000 pounds in a ton. The average American adult emits 20 tons of CO2 a year. And together, all human beings in the world over add 100 million tons of CO2 into the atmosphere each day. That's a ton and tons. Ugh. Hurricanes need lots of warm, moist air to form and stay supply of it to keep them going. And as the sun heats the ocean's surface and the water temperature rises, the warm water evaporates into the air. The moisture, called water vapor, then stays in the air. And sometimes they'll form big hurricanes. The weird thing about global warming is that it will cause harder, faster downpours in places that normally get very little rain. In places that normally see huge snowfall, it will cause more rain and less snow. Heavier rainfall will be more frequent, and lighter drizzles will be less frequent. So in some areas on the planet, such as China, there will be flooding in one province and drought in the province right next to it. That's pretty weird. It says here that though floods have occurred throughout history, they haven't happened that frequently. Global warming is changing that. That's a big flooded farmyard. And it also says that sometimes Floodwaters take days or even weeks to recede, so the pools of standing water become breeding grounds for disease-carrying mosquitoes and other bugs. Gross. Some monsoons can be a welcome addition to a dry region. Monsoons are huge rainstorms. In fact, monsoons are the main source of rainwater for the Sudan, a very dry region of Africa. But unlike hurricanes that form from warmer oceans, monsoons cannot form if the ocean is too warm. Monsoons need a pronounced temperature difference between hot land and cool ocean to start brewing. So if the ocean is too warm, the monsoon never materializes. In the last 100 years, global sea levels have risen 8 inches. Half of it is due to global warming. As water warms, it expands and takes up more space. Ever try opening a new jar of applesauce and the lid won't budge? If you run the jar under hot water, it's way easier to open. This is because the lid expands when it's warmer too. Another way sea levels rise is when land-based ice melts and runs into the sea. Ice is melting rapidly all over the planet, but climatologists are most worried about the Greenland ice sheet. Greenland is the world's largest island, and more than 80% of it is covered in ice. That's a lot. The people living there are settled on a narrow rocky coast. It's hard to believe that 2 miles deep, and is why it's half the United States of ice can melt, but it's already begun to. And it says here that if the Greenland ice sheet melts completely, it will add enough water to raise sea levels across the world by 21 feet. Woo-wee. It says here that here are some of the things that can happen if in your own backyard or close by as the globe starts to sizzle and CO2 levels continue to rise. It says that poison ivy can grow larger and become itchier. Fall leaves can turn a dull color and won't last as long. Ski season can get shorter. Allergies are triggered more and asthma worsens. Outdoor ice rinks can shrink. And disease-carrying ticks and mosquitoes move up in the world. It says here that over the past 200 years, our oceans have absorbed about half of the CO2 emissions that are in the atmosphere from the burning of fossil fuels. That's an enormous amount, which only shows how important the oceans are to a natural carbon cycle. But the oceans also absorb excess heat and solar radiation from the atmosphere. This is making the water warmer. Unfortunately, warmer oceans are putting many coral and fish at risk, big time. Coral enjoys a symbiotic relationship with a certain algae called zooxanthellae. Coral reefs give the algae a safe, sunny home, and the algae provide food for coral. The algae zooxanthellae...
Don't you mean algae?
Oh.
Is it A-L-G-A-E?
Yeah, algae.
It's pronounced algae,
Okay.
not algae. Mm-hmm.
Algae. The algae zooxanthellae also give coral something else in this tidy arrangement. Their brilliant colors. Coral aren't that pretty on their own. They're actually white. The zooxanthellae have bright red, orange, and brown pigments, and that's what gives coral their colors. But when water temperatures rise, the algae cannot...
I think you mean algae.
Algae.
Oh boy.
Messing up on that. Cannot photosynthesize. The chemical reaction that converts sunlight and CO2 into sugars is blocked. This results in buildup of chemicals that poison the zooxanthellae. Scientists are still trying to figure out this next part. In active survival, either the coral spits out the zooxanthellae or the toxic stuff that is built up in the zoo's landfill triggers something in the coral that hurts both of them. Either way, the coral loses its source of color and turns white, almost as if it has grown old overnight. Bleached coral, or what they call coral when it turns white, becomes weaker and more vulnerable to disease, predators, and storms, not to mention becoming a pretty feeble hideout for exotic fish. It also says here that increased CO2 in our atmosphere is making our oceans more acidic. Coral and all shellfish need a certain level of calcium in order to make their hard shells. But higher acidity tilts the delicate balance of calcium in the water, reducing the amount available to coral and shellfish to build their protective skeletons. With some microscopic animals, it can even dissolve their shells. Trees and other plants take CO2 and sunlight in to produce their sugars, and they give out oxygen. And they store that CO2 and other things in their place. But if a tree is cut down, it lets out the CO2. So the more trees we cut down to make things like paper, logs, anything that we need, the more CO2 is released into the atmosphere. The fewer trees left standing to absorb all the new CO2 we've yet to produce, there's just no more trees to produce that.
That didn't.
That didn't make sense.
Go back to that because you didn't do a very good job talking about
The
that.
more trees that we cut down,
Trees hold CO2?
they hold CO2
I don't understand that.
and the sunlight.
Where does it say that in the book? I don't think it says they hold CO2.
It says that the more trees we cut down to make paper, the more CO2 is released into the atmosphere. So I think that the tree actually stores a tiny, tiny bit of CO2. Every tree just stores a tiny, tiny bit, just in case for like the winter and stuff. And so it will release it if it's cut down and die. And then
Here.
if it's
Why don't you skip that and I'll try to splice this together because that didn't make sense.
sorry.
You have to understand what you're talking about.
Here are some of the things that you can do to lessen the amount of CO2 that's being put into the atmosphere. You can use ethanol, which is an alcohol-based fuel made from turning starch crops like corn, barley, and wheat into simple sugars. When combined with regular gasoline, it's called E85, which means 85% ethanol and 15% gasoline. It's already widely used in Sweden and Brazil, and ethanol can help reduce your car's greenhouse gas emissions. And nearly all 50 U.S. states have pump stations that now offer this type of alternative fuel. We can use biodiesel, which is another alternate fuel made from a mixture of vegetable oil and alcohol. It can power any diesel engine. Some people have gone a step further and converted their modern diesels to run only on vegetable oil. That's pretty weird. But we can use wind power. And today, a typical wind turbine, or a really big windmill, like the ones we sometimes see, can generate enough power to run electricity in more than 1,000 homes. Whew, that's a lot. We can use solar power, and though the sun is about 93 miles away from Earth, it can power anything from pool heaters to cars.
93 miles?
93 million miles.
I was going to say, huh?
I missed the word there. Away from the Earth, it can power anything from pool heaters to cars, as long as harnessed properly. Solar panels, solar hot water systems, and solar thermal heat. Power stations have three ways to use the sun's energy. They work by collecting the sun's heat, transferring the energy through the pipes to your home, or directly to the grid that supplies power to a whole city. It says down here, Dell Winston School Solar. There's this.
What? Can you say that again? I don't
The
understand.
2006 Dell Winston School Solar Car Challenge, with cars powered by nothing but the sun. Right there. I think that's pretty weird. Cars powered with nothing but the sun. We can use geothermal power. The word geothermal literally means earth heat. If you travel 10,000 feet below ground, the temperature of the rock will be high enough to boil water. If water deep down the earth gets heated by this rock and comes up this crack in the earth's surface, this phenomenon is called a hot spring or geyser. In Iceland, many buildings and swimming pools are heated with geothermal hot water. Even power plants can run on geothermal power. We can use power. And if you've ever been tossed and turned about by an ocean wave, and you understand the power of water, hydropower uses moving water, either from rivers or dams, to create energy. A hydroelectric dam works by holding back water behind a wall. The water is then released through a pipe and pushed against blades in a turbine, causing them to turn. The turbine then spins a generator and makes electricity, which travels over long distances to places like your home, school, and stores. And then there's biomass power.
What?
There's biomass power.
Say that one more time. I don't understand what you're saying.
Biomass power. It's just a different kind of power. It says here that, believe it or not, dead trees, yard clippings, wood chips, straw, underbush, switchgrass, and composting material can produce electricity, heat, and fuel. Before this stuff was trash, it was alive, which means that was part of the carbon cycle. And that means it stored energy in the form of carbon. When the plants were alive, the photosynthesis process took the sun's energy and converted it into carbohydrates. The energy is then recaptured when biomass is burned in huge boilers. The heat released from this process is used to turn water into steam, which turns a steam turbine to create electricity. Recent discoveries have even found a way to convert leaves and plant stocks to the alternative fuel, ethanol. And then that's it from the Down to Earth Guide to Global Warming.